Hello, students. I'm going to go very quickly through what we covered in class yesterday, which was our learning check over the lactase CER. If you have not turned that in, stop your video right now and turn it in right now. You cannot turn it in after you've watched this video because I'm giving you the answers. Okay, so here we go. So this is a learning check over lactase. Lactase is an enzyme that breaks down the lactose, sugar in milk. The ASE tells us it's an enzyme. The OSE tells us it's a sugar. That's just a little free extra information there for you. But so lactase is an enzyme. That means it's a protein. And so, since it's a protein, it has to have DNA that codes for it. So, it has to have a gene that will code for this lactase protein to be made. If there's a mutation in the lactase gene, that will cause the lactase enzyme to stop working, and therefore, lactose, the sugar in milk, will no longer be broken down. So, as you go through this, and you can stop and take a look at what you did for the mRNA, make sure that if there's a T in DNA, you're matching it to an A in RNA, and A in DNA matches to a U in RNA because there are no T's in mRNA. And then C's match to G's. Over here, G's in DNA match to C's in RNA. Then you're going to find each of your amino acids. Here's the list of amino acids that you would find using your codon table. And we get on to this next part. Does this gene produce the correct shape of protein? Yes, it does. How do you know? The DNA, the mRNA, and the amino acids are all correct. This is the lactase gene. This is the correctly functioning gene. So we should have then the correct shape of protein. Everything is correct. What's the function of the lactase protein? Well, we can find that up here in this little blurb, this little paragraph, and it is to break down lactose. So it tells you right there, lactase is an enzyme that breaks down the lactose sugar in milk. Then we're going to look at our second part here, which is the mutated lactase gene. And so when we look through this, we're going to find that there is a mutation. There's a point mutation. You don't have to know that, but that's what this is, because there was an A in the original strand of DNA right here. And down here in the mutated lactase gene, there's a T in the strand of DNA where that A should have been. That gives us a different mRNA. So there's an A here where there should have been a U. And when you look at this UAA, that gives you a stop codon. That tells the ribosome that this is where we're going to stop making this amino acid. That's like the end of the instructions. Okay, we're going to wrap this up, package it, ship it out. And so you can see that there's part of this amino acid chain that is not being made. It no longer exists. And you could have filled these in if you wanted, or you cannot. It doesn't matter. But this is where the amino acid chain would end. So does this gene produce the correct shape of protein? No, it does not. How do we know? Well, there's a change in the DNA, and that means that the mRNA is different. So there's the mRNA, and that gives us a different amino acid chain. It stops early. You can put that in. That's a nice thing to add in there. And so the protein will fold differently. So if we're going to look at the function of this lactase protein, it will not break down lactose. Why? Because it has a different shape, and shape determines function. Now, you don't have to tell that part here. You're going to talk about that down here in the reasoning. I saw several of you go through the reasoning and do a very simple copy and paste in from the sickle cell anemia CER. You can copy and paste the template, but you probably should not copy and paste the exact answers from something that is different into a scenario that is not the same. Those answers were specific to sickle cell anemia. They were not specific to lactase. So some of you, you got a message about, oh, let's not copy and paste. Let's actually put our thoughts in here. So we're going to use the same format here, though. The ATA is changed to ATT, so that's our change in DNA, because we're answering here, describe how changing the DNA sequence changed the shape of the protein. So you're going to have to start with the DNA. So start with telling what the change is here. That causes the tyrosine to change to stop, And so that gives us an amino acid chain that is shorter. And so when it's shorter, the chain's going to fold differently. That gives us a different protein shape, which does not allow the protein to break down lactose. It does not allow the lactase protein to break down lactose. So the second question here, tell how a protein's structure, its shape relates to its function, and that would be how it works or what it does. The shape of the protein determines the function of the protein. Shape determines function. Shape determines function. And that is always going to be true. So this one, as long as you're not being specific in this one, this kind of can be copied from one place to another because this is consistently true. The shape of the protein determines the function of the protein. And that is the relationship. You can add to that and say if the protein is not shaped or folded correctly, then the protein will not function correctly. But you need to have this main relationship in here that says the shape of the protein determines the function of the protein. And then the last question is to describe the impact of this mutation on the organism, and this is the lactase gene mutation. The impact of the lactase gene mutation is negative because the body can no longer break down lactose sugar. Once you have gone back through and studied, corrected what you need to here, spent some time reviewing anything that you need to, then you can go ahead and start working on the work for Wednesday, December 2nd, which is going to be your summative. If you did get a 4 or a 5 on this learning check, this MSLS 3-1 learning check 2 lactase CER, if you got a 4 or a 5 on that, and you can find your grade on that by looking at your actual paper. Up at the top, it'll tell you how many points it's worth. If you just open up the assignment, you're going to have to actually look into your own specific assignment to see how many points you got out of 5. But if you have a 4 or a 5, you do not have to take the summative that I have assigned to you for Wednesday. All right, this is what we did in class. Hope you guys have a lovely Wednesday, and I'll see you soon.